Alright guys, this is section 8.2, graphing rational functions. These slides I did have to write on the smartboard, so if you would like to have them laid out a little better, you can go ahead and use your textbook, okay? Along with this video, please still pay attention to this video and write notes. Your I can statement for this chapter, or for this section, is can you graph, I can graph rational functions. Remember, your calculator, huge asset here, but we still are going to talk about the different properties. Okay, so here is the parent function you guys are going to work with today. F of x equals 1 divided by x. So now instead of in the exponent, your variable is in the denominator. This graph is called a hyperbola. Okay. If you graph that in your calculator, you'll see it makes a really unique shape here. It gets these two symmetrical sides of the graph. They're called branches. Okay, and you will have them going with specific points. Remember, you can make an XY table to help you figure this out. For example, we obviously can't put a 0 in there because you cannot divide by 0. But one of the points, if x is 1, 1 divided by 1, you get y as 1. So 1, 1 is one of the points there. Okay. Again, I did just kind of sketch it real freehand, but you guys know enough by now to make that XY table. The hyperbola has two asymptotes. It's got a horizontal and a vertical. Both axes are asymptotes. And if you think about that, it makes sense. You can't have x be 0 because you can't divide by a 0. And you can't go 1 divided by a number equals 0. Neither one of those makes sense. So they're both asymptotes. Okay. Another characteristic of the parent function is the domain and range. If you look at the spread of our x's, here x are going to be, not positive. They're going to be all real numbers except 0. And the same with range. Range can be all real numbers except 0. And I bet you're wondering if that's going to change depending on where our graph might shift to, and it will, and we'll see how. Okay, so we want to graph that function, y equals 6 divided by x. When we do that, we're going to make an xy table. You pick values of x, that makes sense. We're dividing with a 6 here, so let's pick factors so that you get nice points. Plug in -3 for x, you get 6 divided by -3, that gives you -2. So one of your points here is going to be -3, -2. And you guys are wondering what this graph in the green is for? This graph in the green is your parent function. Because the other part of this example is they want you to compare it with the parent function. So just ignore the green for now. Okay, we continue plugging it in, you end up with -3, and again, I'm just picking these points, plugging them in for x. -6, 6, 3, and 2. Okay, so we're going to go -2, -3, that's about there, -1, -6, about there. Then we get 1, 6. Two, 3, 3, 2. So we're going to fill in our points there. I wish I made a better looking graph. You can get a really nice graph on that calculator. Okay, so there's my graph in the red of y equals 6 divided by x. You can see that it got more stretched out than your parent function. Okay, so when you have a different number in the top, a bigger number than 1, it's going to stretch your function out.